Welcome. In this video, we are going to look at caching, one of the most powerful and most misunderstood mechanisms in system design. We will walk through where caches live in a tiered architecture, what problem each one solves, and why getting them wrong can be just as costly as not having them at all. Imagine a news homepage. 1 million users load it in the same hour, and every single request hits the database to fetch the same headline data. The database did not change between those requests, but it still did the work 1 million times. This is the core pressure. Repeated reads of unchanged data pile up into serious latency and serious infrastructure cost. And the deeper in the stack the data lives, the more expensive each round trip becomes. Think of a large office building with one archive room in the basement. If every employee walks down for the same popular reference book every time they need it, the stairwell jams and the archive is overwhelmed. So you photocopy the relevant pages and leave copies on each floor. That is a cache. The closer the copy is to the person who needs it, the faster the answer and the less traffic the archive sees. Caching in software works exactly the same way, except we can place copies at multiple levels simultaneously. Here is the key insight. Caching is not one thing you bolt onto a system. It is a layered strategy. Starting from the user and moving inward, we have the browser cache on the user's own device, a CDN cache at edge servers around the world, an application-level cache, such as Redis sitting beside your servers, and finally, a database-level cache built into the database engine itself. Each layer intercepts requests before they reach the next, so a hit at the browser means zero network traffic, and a hit at the CDN means zero load on your application servers. Follow a single request through the stack. The browser first checks its own local cache. If the resource is fresh, the trip ends right there. On a miss, the request travels to the nearest CDN edge node. If the CDN has a valid copy, it responds without touching your servers. If not, the request arrives at your application server, which checks Redis or memcached before touching the database. The database itself has a buffer pool that may satisfy the query from memory rather than disk. Crucially, on the way back, each layer stores the result, so the next request is served from whichever cache is closest to the user. Caching gives you dramatically lower latency and the ability to absorb enormous read traffic without scaling every downstream tier. But it introduces two problems that trip up almost every team. First, staleness. A cache stores a snapshot of data, and that snapshot can go out of date. Second, invalidation. Deciding when to evict or refresh a cache entry is genuinely hard. Phil Carlton famously called it one of the two hardest problems in computer science. There is also the cache stampede, where a popular entry expires and thousands of requests all slam the database at exactly the same moment. The practical rule is simple. Cache data that is read frequently and written infrequently. Product catalogs, user profile lookups, and rendered page fragments are good candidates. Place the cache at the tier closest to the consumer, but only as close as your freshness requirements allow. A financial balance cannot sit in a browser cache for an hour. A product image can. Always set an explicit time to live and design your invalidation strategy upfront. The most common pattern is cache-aside, where the application checks the cache first and only populates it on a miss, keeping the application in control of what is cached and when it expires. To summarize, caching is a layered strategy, not a single tool. Each tier browser CDN, application server database, can hold a copy of frequently requested data, and each hit prevents unnecessary work further down the stack. The gains in latency and throughput are real and large, but they come with the responsibility of managing freshness and invalidation carefully. Get those right, and caching is one of the highest leverage architectural moves available to you.